Cool. So my name's Will. I work for a database company called Neo4j. How many folks are familiar with Neo4j? Just curious. Oh, okay. Great. Perfect. So I work on a team that we call the Neo4j Labs team, which is, rather than working on the core database itself, focused on building integrations and tooling around the database. So one of the projects I work on is our GraphQL integration. So first of all, if you're not familiar with Neo4j, let me say just a little bit about Neo4j. This talk is not really about Neo4j, but in some of the examples, it might help to have a little bit of context here. So first of all, Neo4j is a graph database. So instead of tables or documents, the data model is a graph, so nodes and relationships that connect nodes. Specifically, this is called the labeled property graph model. We use a query language called Cipher. You can see an example in the upper right of Cipher. We'll see a couple of examples of Cipher, so it's helpful to understand a little bit about Cipher. Basically, what we do with Cipher is draw these little ASCII art graphs that represent traversals through the graph. That's basically the basic idea there. So by the way, if this sounds interesting to you, Neo4j is hiring. These are just some of the jobs in our London office. So check that out at neo4j.com/jobs or chat with me a bit if this sounds interesting to you. Okay, so the labeled property graph is the data model that we use in Neo4j. And the reason I want to talk about this is because when we get to talking about our GraphQL integration, we'll see how we sort of map GraphQL to this property graph model. So we have nodes. These are the entities in our model. Nodes can have labels, which in our GraphQL integration, we map to types in GraphQL. Then we have arbitrary key value pairs that we can store on nodes or relationships. Relationships have a type and direction, and they connect nodes. We can also store properties on relationships. So that's the basic data model. And we use Cipher, this graph query language. Think of it as SQL, but for graphs. Here we are drawing sort of the ASCII art representation for two nodes. So nodes are within parentheses. The labels follow the colon here. And you can see the properties within curly braces. So here, this is a create statement. So if we ran this in the database, we'd create two nodes, one for Neo4j, one for this city, San Mateo, with this located in relationship connecting them. So I want to talk about some of the underlying things we use in our Neo4j GraphQL integration, and specifically this integration. So Neo4j GraphQL.js. So this is a JavaScript library that works with any of the JavaScript GraphQL tooling to make it easy to build GraphQL APIs. So an important distinction here, when I'm talking about a database integration for Neo4j and GraphQL, we're not talking about turning GraphQL into a database query language. We believe that you still, with GraphQL and database integrations, are often interested in building this API layer that sits between the database and your client. But we want to make tooling that makes it easy to do that. So specifically, what we do with this integration is take your GraphQL type definitions, and from that, we generate a GraphQL API. So we add query mutation types, we add complex filtering, arguments, pagination, ordering, and then the really neat thing is that we auto-generate resolvers for data fetching. So you basically get a CRUD GraphQL API for free with just your GraphQL type definitions. And it's meant to be in a very flexible and extensible implementation that works with any of the JavaScript GraphQL tooling like Apollo Server, which I think is most commonly used with our users for this. This becomes part of what's called Grandstack or GraphQL React Apollo Neo4j database. So if you hear people talking about Grandstack, this is what they're talking about. Our GraphQL integration is kind of at the heart of this. Okay, so there's a few things going on with Neo4j GraphQL.js, but there's two basic jobs that it's doing. One is this schema augmentation, where it's taking GraphQL type definitions and adding query and mutation types, filtering input types for all of this. Also adding types that expose native database types like date, time, and spatial. And then the other part is basically what enables these auto-generated resolvers, where we are essentially taking the GraphQL request and generating a single database query. So essentially generating Cipher from a GraphQL request. And it's the second piece that we're going to focus on in this talk. So I'm not going to try to convince you in this talk that a graph database is the best backend for a GraphQL API, even though you have some nice benefit of having the same sort of data model. Instead, my goal is to convince you that this GraphQL ResolveInfo object is not scary, and it's something that we can actually make use of inside our resolvers to build efficient database queries. So that's the focus anyway. Okay, so let's look at maybe a motivating example before we dive in. So I was at GraphQL Summit in San Francisco back in October, and I thought it would be fun to have a GraphQL API for the GraphQL Summit conference schedule. So I just wrote a little scraper to scrape the website for the conference schedule, and I loaded that into Neo4j, and then used our GraphQL integration to expose a GraphQL API of the conference schedule. So the code for this is online. That bit.ly/summitgraph links to a GitHub repo that has the code and a README to get it started. It's running online as well, backed by one of our Neo4j cloud instances. Let's see if we can query this. Make that a bit bigger. So if we look here at the docs in GraphQL Playground, we can see here's our query and mutation fields that we have available. So we can start by searching for speakers or companies that are connected to speakers, or start by searching for a session. And we can see here that we can pass in a session filter. So we can search for like sessions where the title contains some value. And then from there, we can sort of traverse out through this data graph. In this case, here's the query we're going to run. So we're going to search for sessions where the abstract contains resolver. So what are all the talks about resolvers? And then give me the title of the session, what room is it in, who presented it, who do they work for. And then we have this recommended field that if we look here, this recommended field is giving us well, zoomed in a little too much. If we look at recommended, it's giving us basically other sessions. So if we're interested in this session that we're looking at, what are other similar sessions? Okay, so we run this and we get back some sessions, yep, where the abstract contains some information about resolvers, and we get back some recommended sessions we might be interested in. So all of the code to build that fits on the screen here. It's a bit small, so we'll look at this in a bit more detail. But basically on the left, we have our GraphQL type definitions. So we have basically speakers, sessions, companies that they're connected to, and so on. So if you've ever written GraphQL type definitions, this should look pretty familiar. And then on the right, basically all we're doing is pulling in these type definitions, passing them to this Neo4j GraphQL JS integration to get an executable schema, and then passing that to Apollo server. We also, here we're creating a connection to a Neo4j instance with the Neo4j driver, and we just inject that into the context here, so it's available inside our resolvers for Apollo server. If we were to run this same sort of query, but in Cipher in Neo4j, so this is a screenshot of Neo4j browser, which is like a query workbench for Neo4j. So up at the top, this is a similar query, but now in Cipher that says find sessions where the abstract contains resolver, and then traverse the graph a little bit to find who presented that session, who do they work for, and we get back sort of the graph representation of that in Neo4j. If you want to see the code for how this works, it's online. Also, that bit.ly link just points here as well. So okay, so we weren't writing any resolvers here. So there was some bit of magic going on that let us basically fetch data and generate this database query without writing any resolvers. So what's powering that magic? Well, that's mostly powered by this GraphQL ResolveInfo object. So how can we use this to build efficient GraphQL APIs? So first of all, let's back up a little bit and talk about what is a resolver. Well, neither of these things are resolvers, but the thing on the left, that's our GraphQL type definitions. So basically saying we have sessions that are connected to speakers and so on. And then on the right, this is the query we just ran. So find sessions. We're passing in some search string. So find sessions where the abstract contains some value, then traverse that graph a little bit and return some info. And the resolvers, that's what get called when we run that GraphQL query, right? So the resolvers are responsible for actually figuring out how to fetch that data from some data layer. It could be another API, it could be a REST API, any database layer, whatever. It's up to the resolver to figure out how to fetch that. And every resolver is passed some arguments. So basically what's been resolved so far, since these resolvers are called in a nested fashion, it's also passed any field arguments from the GraphQL query. We're also passed this context object. So in the context object, notice in the beginning when I showed where we're creating a connection to the database, we're injecting that into the context. So that's available inside all of our resolvers through the context object. And then the last argument is this info, which is the GraphQL ResolveInfo object. So a typical implementation might look something like this. So first we hit this session resolver in the query type, and we might first grab the database connection out of our context, and maybe we have some API that's like show me sessions by some search string, and we'll pass in the search string from our parameters. Then the rest of our resolvers will be called here, and we'll grab, okay, so we have a session ID from here. Now we need to resolve the rest of the session field. So we pass in that session ID that we grab here from the object argument that's been resolved so far, and so on for the rest of our nested resolvers. And there are some problems with this. One is, well, this is a lot of kind of boilerplate code that we have to write. But the big problem has to do with performance, in that for each one of these, we're essentially making a round trip query to the database, right? So it would be nice if we could just generate one database query kind of at the root level here and just send that to the database to just make that one round trip. The database can sort of optimize how to fetch that data from the database. So note here that each of these resolvers is passed this ResolveInfo object. Okay, so we've talked a lot about this ResolveInfo object. What is actually in here? There's a lot of stuff in here. I'm going to go through this kind of quick and then show how we can actually use these. So we have the name of the field that we're resolving. We have a representation of the selection set of the GraphQL query. We have the value of any GraphQL variables that we've used. We have the full query AST. We have any query fragments. We have a representation of the full executable GraphQL schema for our GraphQL service. We have the path, so the fields that we've traversed so far to get to this resolver. We have the GraphQL type of the parent, and then the type of the field that we're currently resolving. So this is all information we have available in this GraphQL ResolveInfo object. So what are some things we can do with that? Well, the first thing we can do is find the nested selection set from the root level. So from that root level resolver, in this case, our session query field, we can sort of look ahead and find all of the fields that are being requested inside that root resolver. And once we have that, then we can generate a single database query from this root level to essentially resolve our entire GraphQL request at the root level in one query to the database, which is quite nice. Another thing we can do is implement schema directives. And this might sound a little weird if you've implemented schema directives a different way. I'm going to show you how we implement two schema directives specific to our integration and why we do it here rather than a different approach. Okay, so going back, just remember this is the query that we're running, starting at sessions, searching for sessions by some value in the abstract, and then traversing out from there. So the first thing we want to do is find from the first resolver that gets called, which will be this session resolver in our query resolvers, can we find the nested selection set? So I'm not going to show you the code that we use to do this because it actually has some things specific to the way that we implement our schema directives. But to find the nested selection set from a ResolveInfo object, Benji from PostGraphFile has released this GraphQL Parse ResolveInfo package that basically makes it very easy for you just to pass in a ResolveInfo object and you get back a representation of the nested selection set for this query. And the reason that's nice is we can then iterate through that representation and build up our database query. In this case, we do it in Cipher, but we could do this in SQL, basically in any sort of database or even sort of ORM layer. So this is what the Cipher query looks like that we end up generating. You can see there's two things going on here. One is we kind of specify the traversal. So we basically append patterns to this graph pattern here as we see them nested in the selection set. We add a predicate, in this case for our filter. And then in the return clause, we're basically specifying basically a representation of that selection set to specify which fields get returned from our traversal that we've done up here. So we have in Cipher, we have the same sort of projection semantics that we do in GraphQL. So if we run that in the database, we get back an object, which we can just return from our resolvers, which is quite nice. We can also get a graph representation in Neo4j as well. Okay, so that's useful. That gets us a big way of solving this N+1 performance problem by generating these single database queries at the root resolver. Another interesting thing we can do with this GraphQL ResolveInfo object is implement schema directives. So if you're not familiar with schema directives, they're basically annotations in the schema that allow us to define some custom server-side behavior. So I like to think of these as GraphQL's built-in extension mechanism on the server. We also have client directives as well, but here we're talking about server directives or schema directives. So we have two schema directives that we use in our GraphQL integration. One, relation, where we attach some metadata to a field. So if you remember when I showed that diagram of the labeled property graph model, and we said that every relationship has a direction and a type, that doesn't quite map exactly to how we represent relationships in GraphQL. We have some additional metadata for the direction and the type of the relationship. So we just attach this metadata in our type definition, so that's available when we generate our database queries. And the next directive that we have is a bit more complex. So oftentimes we have some custom logic beyond CRUD that we want to add in our GraphQL layer. So the example we saw in our API was finding recommended sessions. So if I've searched for a session and I'm looking at it, what are some other similar sessions that I might be interested in looking at? And those kind of recommendation queries are really easy to express in a graph query language like Cipher. So here, basically what we're saying is this. So for the currently resolved session, traverse out and find other sessions that are in the same track or have the same theme, and then return those as your recommended sessions. And that's fairly simplistic. We could do a lot more complicated things here, like collaborative filtering, content filtering, that kind of thing. But that's the basic idea here. Defining some custom logic, then binding it to this recommended field in our GraphQL schema. And when we generate our database query, this will be attached as a subquery. So we have this sort of custom logic without having to write the boilerplate code, making a connection to the database, fetching that, dealing with the results. And we get the benefit that since it's run as a subquery, it's still one round trip to the database. Cool. So that is the Cipher schema directive. And if we look at the generated query, then this becomes the subquery for the recommended field in our projection in our Cipher query that we send to the database. So the way that we identify these is as we're iterating through the nested selection set, we check to see if this directive exists. And because in the ResolveInfo object, we have a representation of the executable schema object, we have that available to go and check if that exists on those fields. Cool, and so here, this is the result that we get now showing some recommended sessions along with the basic fields that we requested. So that's one way to implement schema directives if the logic specifically depends on sort of how you're building up this database query or for how you're fetching that data from your data layer. Other ways to do this are using some of Apollo's GraphQL tools library that gives you a nice API for implementing these directives. We use this approach for the way that we implement authorization in our Neo4j GraphQL integration. Okay, so that was kind of a quick overview of some different ways to use this GraphQL ResolveInfo object. Hopefully, I convinced you that it's not this super scary thing, that there's some useful data in there that you can use for building efficient database queries and data fetching logic in your GraphQL resolvers. I just want to end by pointing out some resources. Again, if this sounds interesting to you, Neo4j is hiring. Definitely talk to me about career opportunities there. Also, some other resources talking about the GraphQL ResolveInfo object, this blog post from some folks at Prisma. Also, this video from Eric Baer at one of the early GraphQL summits that goes into a bit more detail about this. I'm working on a book published by Manning, Full Stack GraphQL, that talks a lot about some of these concepts. There's an early release out now, so if that sounds interesting, check that out. I mentioned Grandstack, this sort of full stack framework that shows how to use these components together. A lot of the documentation and examples is available on the site Grandstack.io. Some of these other links I'll just leave for you to check out in the slides, which if you're interested, the slides are available here at bit.ly/ResolveInfo. Cool, and that's all I have. Thanks.